I'm a mechanical engineer major, sophomore. Um, I joined GSOE in last semester. I'm working on the yaw and tower component of it. Yeah, I'm excited to learn more about the wind industry. I've only started learning about it last semester, but it's like very cool. I think I'm considering like going into working there like for the rest of my career. I'm excited to learn about it.
Okay, great. So I guess ground
Yeah.
me a little bit. What is GSOE? I'm not familiar with that org or
So there's the collegiate wind competition, which is basically we make a small scale wind turbine for like an offshore replica, and we compete in Minnesota to like with the 12 top schools. Basically, like we just designed the whole wind turbine. It's in the background over there. You see the
okay,
top of it.
nice.
But yeah, so it's just like a group. We have a mechanical engineering group, like the mechanical design, and then we have the electrical design. Those are like the two main parts that make it.
Yeah,
I
and
just
oh, sorry.
I was just gonna ask what GSOE actually stood for.
Oh yeah.
Grove School of Engineering. Yeah.
Okay,
Yeah, yeah. Yeah, I actually didn't know that either until until I joined. But that is the school we go to.
okay, understood.
Yeah, it's the engineering school, part of City College, and
Yeah.
it's City College's first time competing in this wind competition that the Department of Energy is hosting. And so we're participating in the collegiate wind competition as a wind team.
That's
Okay,
great.
so it seems like nobody is trickling in, but I'll be recording this so that we can share out to our students. We have like around 30 members of the WIN team, but some of them are in classes today, so they might not be able to join live. So, welcome everyone. Like we said, we're GSOE Wind, and this is Jeremy Thorsen, who was who we're having a pleasure to interview today. Your Jeremy is a systems integration leader at GE Vernova, and he'll be telling us more about what he does, his experience in the wind industry, and how he got here. And there will be time for a Q&A during the later part of the session. And this is Elsa, and she'll be doing the interview. And yeah, you can get started, Elsa.
Okay. I guess we'll just start with like if you could tell us about like your journey to becoming in your position right now and like what you've had to do since college to get there.
Yeah, be more than happy to. It's actually a very atypical journey from most other of my peers. Happy to kind of go back. So, I've been with GE Vernova, which has been GE has changed name to this part of the business multiple times over the year, but it's currently GE Vernova. For 15 years. Actually, today is my 15-year anniversary with the company. So 15 on the nose. That goes back to my time as an intern at the GE manufacturing plant in Pensacola, Florida, where we make our nacelles, our machine head. We call it the machine head, but it's the nacelle. So the pretty much the drivetrain of the machine and the hub, which is the nose cone of the rotor. We manufacture those in Pensacola. I got an internship there back in 2006 while I was a student at the University of Florida satellite campus at the University of West Florida, Pensacola. It was kind of like a joint engineering program. Did about 2 years worth of interning there. Much longer than your typical internship, but I'm from Pensacola, born and raised, so I was basically staying home and getting that experience, in my hometown, and the pay was decent for a college student in that town. So they kept extending my internship, so I stayed on board for about 2 years. At that point, I had to tell them it was time to finish my degree. So I left, transferred to the University of Florida to finish my degree on the main campus in Gainesville, where I graduated in 2010 with my degree in industrial and systems engineering. At that point, they had a position back at the factory waiting for me as a quality engineer. So I started out my official career with GE post internship as a quality engineer in that same manufacturing plant. Did that for about a year. That role was a lot of day-to-day firefighting when things don't quite go right at the assembly line. There's problems, there's issues, things like that. I was the first line of defense to kind of solve those problems. That required a lot of cross-functional work between the manufacturing team, the shop floor managers, um, was kind of the quality organization, working with engineering and that sort of thing. Then after I finished that role, I moved into an operations leader position. So I managed one of the assembly lines on the shop floor in the same factory. I spent 2 years doing that, and then I kind of took a step away from the product itself a little, as far as the direct responsibility for building or the quality of the product. I did 2 years as a facilities engineer in the same plant, working with the facilities team. They own the infrastructure, so the building itself, security system, HVAC, the cranes, electrical system, a pneumatic air system, all the stuff that keeps the plant running on a day-to-day basis. That team owns that. So I spent a couple years doing that. The manager there was my manager back during my internship days. So that was kind of like my original mentor within a company. So he had an opening and I joined his team. After that is really where I spent the longest at any point in my career at GE. I spent 6 years as the design liaison engineer, which I think was what you guys knew me as from Jessica when she sent you my way. That role actually was a transition from working for the factory in the manufacturing team or supply chain, really is kind of the organization, moving into the engineering organization. They're really separate organizations within the same company. So I was at design liaison. Is exactly like it sounds. I was the go-between between manufacturing and engineering. That role was very unique because I was kind of had one foot on either side of the fence. I worked for engineering, but I still, my end user, my customer was manufacturing in a lot of ways. I was able to leverage my experience in manufacturing from the previous years to help me, be successful in that role. I spent 6 years doing that, and then the 2 years prior to this year, I just changed roles recently, but the 2 years after that is I joined the team that Jessica was on when she was with GE Vernova, as a repair engineering. So we were in charge of repair development for major component exchanges and things like that for field work. So then, like I said, this year, as of about a month ago, I transitioned to the subsystem, the machine head subsystem team is what we call it. So we're responsible for kind of the coordination of all the systems that go together to make up the machine head within the cell, is what you might be more familiar terminology wise. I've been in that role now for about a month. So not a lot of depth there. I could probably go, explain to you there, but I'd be more than happy to go through the, any details in the previous 14 years or 15 years.
That was great. Thank you. So can you just tell us more about like your responsibilities right now or like throughout your roles maybe?
Yeah. So, I guess I guess spend the majority of the time there really as like the design liaison, right? I think that's probably the one that's the most useful knowledge for you guys. So, that role was very unique, and it was very, when I said atypical as far as my journey goes, you don't see, most of my peers did not come from like a manufacturing background or supply chain organization or even educational wise, right? A lot of the people in the actual design engineering team within GE are your traditional mechanical, electrical, materials engineering, things like that. My background was all based around manufacturing and process at that point, but I had a lot of experience in that area, and that lends itself to being a good fit for that DLE role. So in that role, I kind of did a bunch of different things there. So the first one was I mentioned earlier, when I was a quality engineer, I was the first line of defense against things that went wrong in the assembly line. If there's an issue that comes up that requires engineering input or disposition on a problem that goes beyond what the quality engineer could do, the DLE is that first kind of stop for them. The main reason we have design liaisons throughout our factories throughout the globe is we are a global team. So a lot of the individual component and system design engineers don't always sit in the same time zone as the manufacturing plant. So in an effort to not stop the line and stop production every time a problem comes up, you want to have some boots on the ground, somebody right there in person in front of the issue that can make some of those judgment calls, that can do some of that engineering analysis to understand what the right path is to fix and correct the issue going forward. So if you had to wait for an answer from somebody, let's say works over in India or China and Germany, which are the other three major hubs of our business, you would delay production substantially if you're, having to operate with that sort of rhythm. So design liaison is sort of that first person on the ground, right here in front of the problem, see the problem, what's going on, and try to solve it that way. Now, it's not to say that we would not, need to go consult with different component owners and systems owners from around the company, but more times than not, you had that ability to be right there and solve those problems. So that's sort of the serving manufacturing from terms of engineering. So another function of that role is to really be the eyes and ears of engineering, to ensure that their design practices and their design intent is being met in the manufacturing processes. In theory, that's mainly just like sort of approving work procedures as they get written and amended. What you're really kind of doing too there is kind of being the eyes and ears and just being observant, noticing things, monitoring things, making sure, hey, this it doesn't look right, stop and ask questions. Because at the end of the day, you're sort of the one responsible for making sure that design intent is met, right? So the design engineers will design the turbine, all the different components and the systems that go together. And it's pretty much all done essentially on paper, right? With modeling and things like that and simulations. That doesn't always match the reality of what's being assembled and the processes that are actually going on the actual shop floor. So your job is to kind of bridge that gap. So there were a lot of times that I would find an issue that was maybe not realized because we didn't have the right instructions in place or the right understanding of why something was designed the way it was or why it should go together a certain way. And then at the same time too, going back in the other direction, sometimes the design just didn't make sense from a practical standpoint because it couldn't be assembled very easily or reliably or the high level of quality, or safely for that matter. And I was sort of provide a sanity check for design engineering to say, hey, if you guys make this change, it's not going to work because of X, Y, Z. And you'd explain sort of the manufacturing process that goes behind it. So it really was a true sort of, liaison, go between the two organizations.
Can you tell us like a story about like one of your most challenging like or difficult tasks that you had to overcome, like when you were a design liaison?
Yeah,
Like
so
something you
it's
like got over and like how you were able to overcome it?
yeah, so the one of the interesting aspects about that work is you serve you basically are the your end customer, like I mentioned, is manufacturing. So you have to to make sure that you're understanding of the challenges that go with manufacturing and that sort of thing. And coming from my background, I was very good at that. But at the same time, like I also mentioned, you are responsible for ensuring design intent is met from the engineering side. There were many times we'd have some sort of quality issue that would come up. Usually it's cut and dry, hey, this is an engineering problem or it's not. It could be a supplier related defect. It could be a manufacturing caused defect. Um, the engineering design issues are usually pretty straightforward. Hey, this isn't right, so we have to fix that. It's the ones that aren't as clearly evident right away that you start to get into the realm of needing to sort of play both sides of the fence and be that a true liaison. So I could think of an example where a particular bolted joint, so the bolted joint that holds our pitch bearings to the rotor, right? So you have the ring that the blade pitches on to control the speed of your turbine. We had a quality issue with the bolted joint. We had bolts that were loosening in the field, and we traced it back to, at least initially, we traced it back to some questions around the manufacturing process, how those bolts are being torqued, the tooling being used, and the requirements for the torquing. Can't get kind of too into the technical details with all of that, but that was a multiple week sort of root cause analysis to dig down and really understand through multiple trials and tests and analysis to understand, hey, we have this engineering requirement. It says if you do torque it to this torque value plus this additional angle, you're going to get this amount of elongation in your bolt, and we know that provides this much clamping force in the joint. You shouldn't have any issues, but you guys are torquing to this and we're getting this output. and it doesn't match what it says we should match. So there's something going on there. So a lot of finger pointing between manufacturing saying, no, this design's crap. And then there's a lot of finger pointing from engineering saying, no, you're not following the CTQs, the critical to quality, the aspects of design requirements. That particular instance, I was really caught in the middle there of seeing both sides of the story and seeing, hey, in reality, manufacturing is thinking they're doing the right thing. Engineering, I know we have this requirement that we're saying should make it work, but there was a disconnect there with actually the way the tool operated, the way the tool measured torque, and the way that a bunch of variables stacked together between the tooling and the material of the hardware itself, friction, a bunch of those things played into it, to where it was really kind of more of a overarching system problem versus just one specific problem that was caused by one organization or the other. So that was a very challenging time there to sort of lead the way through that, and to come to what was the final resolution of really changes on both sides, to get to where we were sending out good product again.
In that example, was it already in place? Like you guys built it fully, or was it like almost gonna be sent out?
Oh, this was multiple units. It was a
Mhm.
escaping defect, basically. So I don't remember the count off the top of my head, but there were some number of units in the fleet. They were finding these nuts backing off and loosening, and that triggered the investigation into why, which led to some analysis of measuring the torque and measuring the elongation of the bolts, and understanding what the tool is actually doing, and understanding what the requirements were, that sort of thing. So it was a fleet-wide impact there that required rework in the field, which is where we don't want to do. We want to catch those things in the factory. That's the whole idea, is to catch things in the factory up front. Don't let any defects escape. This was a escaping defect that required quite a bit of work to figure out why the defect happens, so you can stop the bleeding and then go make your corrections.
Okay. So we'll move on to what you like about your job and like what you enjoy doing on your day to day. Do you guys go like out into the field a lot, or are you mostly in the office?
So it depends. So the role I am in now is less field work, more office work. I do still physically sit in Pensacola. Right now, I'm actually working from home remotely because they're doing some renovations to the office space, and I'm not considered essential to the day-to-day factory anymore. So I pretty much work at home unless I need to go in there for something. What I like about my job, at least where I'm at, is I have the proximity to the product. I've never been one that could sit in a cubicle for 8 to 10 hours a day and just do straight design work on a computer. I like getting my hands dirty, like getting my hands on the parts. So that's for manufacturing. That's why I was sort of drawn to that part of business when I first came out of college from my experience as an intern. So even in this job, and now I have the ability to go put my hands on the product. Field visits are there'll be a little fewer and farther between with my current job. Now, the previous 2 years where I was a repair engineering systems integration leader, that opportunity was much more frequent, because anytime you had to go validate a repair process, you would go to the field onto a turbine and do that actual validation. So
Can you talk about like your experience starting at your internship? Like you started mid-college, right? So you took a gap year working full time, or did I like
you
misunderstand
can,
that?
yeah, gap years, plural, you could say.
Okay, yeah.
Yeah, so I was probably, let's see, I started in 2006, so I was somewhere between kind of my sophomore, junior year of college.
Mhm.
I was going to school at the University of West Florida, which is a smaller school in Pensacola, but that engineering program was tied to the University of Florida, our flagship state university down here. So I was basically living in Pensacola and working towards my, at the time, electrical engineering degree at UF. I had a friend of mine who was interning at the GE factory, who was kind of my foot in the door there. They had essentially I was his replacement, so they had a posting for the position. I applied and ended up getting the position. Um, Supposed to be for 2 consecutive semesters, and I would go back to school. But I was kind of, got my foot in the door there and got into some really interesting projects. Kind of at that time, the manufacturing engineering division was sort of combined with the facilities engineering division within the plant, so that the same manager owned all the manufacturing processes and tooling and the building and the grounds. So I worked for him on kind of projects that sort of dabbled in both. At the end of my second semester, they offered me another semester extension, and I accepted it. And then that kind of snowballed into multiple extensions beyond that. I was there for 2 years plus a summer. And in the interim, the University of Florida parted ways with the University of West Florida. So that joint program was no longer there. So I had to transfer to the University of Florida main campus in Gainesville to finish. Like I think I mentioned that earlier, but yeah, so I basically did my 2+ years of intern in Pensacola, which is what obviously got my foot in the door, built the reputation with the factory team, and had a position sort of waiting on me when I finished school.
How did you go about setting up the position? Like when you got out of school, like you just made connections in that job and they offered you before? Like did they tell you to go back to school and then they'll give you a job? Or was it like you applied again and went?
So yeah, the expectation, who's to say how long they could have kept extending me, right? I didn't want to be a career intern, right? So I had to tell them,
Yeah.
hey guys, this is my last semester, because it was as far as course offerings at that time, I wasn't really able to make much progress towards my credit hours to graduate as when I was an intern, because it was a 40 to 50-ish hour a week sort of position, and just the timing wasn't well for when the classes I needed were being offered. So I really did not make much progress towards my degree while I was there. So you can really call it a gap year with years, 2 years of gap with very little progress. Yeah, so I finished the internship, went on and continued towards my degree at Florida. My last semester, so my manager had kind of kept in touch with me over the years. I was only had about a year and a half or so left of school at that point when I finally got there. Um, so he kind of kept in touch with me to make sure I was still on track to graduate. And then the last semester where it was a, hey, this is going to line up. They had a quality engineering opening that came open, and he just called me, if either call or email, one of the two, and asked if I'd be interested. And at that point, I hadn't really put too many feelers out to other companies yet. There was always sort of that understood assumption that I was going to have a job waiting for me in some capacity back at the Pensacola plant. But they reached out and said, hey, there's an opening. So I applied and did the interview was not as probably as comprehensive as a typical interview would have been for that process, because it was sort of a check the box sort of interview, so to speak. But I went through that process and then started basically the week after I graduated.
Okay. What skills do you think like set you for this success?
You mean like when I finishing
Like
college,
just in
jumping into that,
general,
Joel?
yeah. Like beginning and then also like just where you are now, like how do you think you like were were able to do that? Like what made you like unique and like better than other candidates?
So obviously the experience I gained as an intern there at the factory was huge, because I was familiar with the product. Um, my technical acumen, I say would be fairly high, even though I wasn't, your stereotypical like mechanical engineer or anything like that. Growing up working on cars and things over the years, and just sort of building that experience through various parts of life and in school and my internship, I understood those mechanical electrical concepts very well, which lent itself to being good at technical jobs such as a quality engineer. I could look at a mechanical or electrical system and understand it, and which is critical to be able to help troubleshoot it or repair it, fix it, things like that. Communication skills are a big one. I think even that one through today, uh, you have to have that, the ability to communicate and tailor your communication based on your audience. So if I'm talking to a shop floor technician who doesn't understand why we're doing something the way we are, he just knows, hey, I'm supposed to do this and that, and this is the steps, to be able to explain to them why we do things a certain way and why it matters to our customer and why it matters to the operation of the turbine, and then be able to go upstream to a chief engineer at one of the top levels of engineering within the organization, and explain a problem in a technical sense, and then go to kind of in the middle there to like an operations manager at the factory or something like that. To be able to communicate clearly with different sorts of audience based on their technical skills or lack thereof, and effectively is a big one too. And then organization and attention to detail. I think attention to detail is probably up there in the top three as well, from something I feel like I have stronger than others, is that for sure.
Great. And where you are right now in your career, do you want to like move, like change positions again, or you don't know like what's in the future? Or are you happy like with the position you just changed to?
Yeah, so this is probably a longer term. I think the longest role I had within GE was 6 years. That was in engineering. So it's kind of great question, because I kind of explained the differences between my experience in manufacturing and moving to engineering. Manufacturing, there was a lot more turnover, a lot more effort to, hey, work your way through all these roles to get your experience. Every 1 or 2 years, you're changing that next role, that next role, that next role. Then you can move, into some sort of like leadership type position. Engineering is more about acquiring knowledge over a period of years to have that experience in that role, become more effective in that role, and be basically a master of that domain, so to speak, or a technical expert. So the engineering roles tend to be longer. You tend to stay in those roles longer. They're not to say there aren't opportunities to advance, but you become much more effective in those roles the longer you're in them, where it wasn't always the same case in manufacturing. The only reason that I left my DLE role to move to the repairs team, there were some organizational change that happened, and a colleague that I previously worked with in a different capacity when I was a DLE just reached out and tapped me on the shoulder, and had basically what was a promotion essentially available there. He reached out to me and asked me to join his team, which was a promotion, and it was a great opportunity to move into something different. After spending 6 years in the factory as an engineer in the factory, I can get some field experience to understand what goes on out there, because my experience prior to that was very limited to the assembly operations. And then this most recent move was similar in that I was reached out by a former colleague. So one of the my manager now actually is somebody I worked with on that repair team. She got promoted to a manager of this team, and then she brought me with her 6 months later, essentially. But there were some organizational changes that sort of changed what my role had become, and it didn't really align up with what I was kind of there to do initially. So it was a good time to move into what I'm at now.
Do you have like a position that you would want to move to after this, or you think you're like good there for a longer time? Like I know you said you wanted to stay here for a longer period of time, but I'm saying like in the future.
Yeah, for me, I guess where I'm at now in my skill set, I think there probably would be more into a management type role from here, more than likely. But that's probably looking down the road another 5 years or so.
Yeah.
To spend enough time in this role, to because right now I'm drinking from the fire hose. I am still learning what's up and what's down. I'm on the team for about a month now, and I'm still learning so much. And
Mhm.
this side of the business, this side of the engineering organization is new to me. So it will take me some time to become what I would consider competent with this job. And I think at some point, probably 3+ years down the road, I'll start looking at what those opportunities would be right now. But right now, I'm still trying to just in survival mode from the newness of it. So
Okay. That's all for my questions. I just want to open it up for everyone else's questions. I want to say thank you for answering all of my questions. If anyone else has any questions for you. If not, then maybe you could just give like advice to like aspiring engineering students and like how we get started.
yeah,
Um,
so I guess I would say I think anybody you'd ask kind of give you the same answer: get experience, right? Get your foot in the door somewhere. Even if it's not specifically where you want to end up, try to get some sort of working technical experience somewhere. Um, if you want to get into the renewable energy industry, that's great. If those opportunities could be few and far between from an internship standpoint. But look at companies like GE, look at some of our competitors, look at some of our OEMs, those energy companies like Nextera and those sort of places, try to find those opportunities. But if you aren't able to um, find something specifically related to what you want to do, that's okay. Just get them something on the resume where you can show that you can solve problems, where you can show that you could be a leader, where you can show that you can learn and develop. Those are the things that are and communicate, like I mentioned earlier. Those are the things that you really need to develop to be able to demonstrate to future employers.
Mm.
Okay, thank you.
Thank you so much,
Um,
Jeremy. I have a few questions if you can answer.
Sure.
Um, so like Elsa said, we are engineering students, and some are non-engineering students looking to get involved in wind. And something we wanted to know is what should people know about working in the wind industry, and how should we prepare other than getting experience? Are there certifications or trainings? Are there people that are great to connect with, or conferences? What would you suggest?
I would say become as familiar as you can with the industry as possible, the happenings, and everything from um, the PTC, the tax incentives, and the things that drive the industry, right? So you can kind of see how the industry dips and rises and falls over the years of demand, kind of follows our political climate, so to speak. Um, Stay up to date on different technologies if you can, because the technologies have evolved quite a bit even since the 15 years I've been around. I'm looking at what we've been able to get out of these machines without, size of the machine versus power output. That's come a long way over the years. For more focusing on like non-engineering side of things. Um, I kind of on the spot here trying to think of different organizations and publications. I'm sure there are plenty of like newsletters and articles and groups out there you can subscribe to. Um, as far as companies, when I think about GE and the non-engineering side of GE, we do have a commercial arm, that basically our salespeople that work with our customers to sell them the turbines. In supply chain, you have everything from buyers and sourcing to finance. There's, obviously you have to make sure you're counting the beans correctly, right? So we have, finance arm, um, leadership, management, things like that. So really, regardless of what, where your background or your education or skill set lies, there should be something for you within the industry. So I guess aside from getting experience directly and things like that, just find ways to learn, um, find people that are in the industry and within maybe the companies you're looking for, and LinkedIn is probably a great place to start there too. Follow these companies, follow these organizations, follow these individuals, and especially the ones that are actively posting on LinkedIn, things like that, to learn what you can.
Thank you. That's really helpful. Um, I know we've have a LinkedIn group for the collegiate wind competition, so it's been very helpful for finding connections. And you mentioned something about the political climate, and we've been hearing about Empire Wind by Governor Kathy Hochul. Do you know what the future of wind energy would look like in this political climate? Do you see state level politics playing in a larger scale of wind energy development?
So I wouldn't have a whole lot to say on a subject of state level. Um, I guess when I was kind of referring to, I think about what's kind of driven the wind industry over the years are the federal tax incentives to energy companies to build wind versus other forms of energy. Really renewables, but wind is very much more popular than solar for most of these OEMs. Um, we've kind of been in this cycle over the years where so the production tax credit, that's the big driver, right? So it's as long as that's been out there as the carrot, energy companies are investing in wind, and then we get closer to the expiration date, and then orders start dropping off because they're thinking, oh, if it doesn't get renewed, we're not going to get our tax incentives of building wind. So it's really kept the industry cyclical. That's gotten better in recent years as they have extended those tax incentives. They've put more stability around when they expire, how they would taper out. I don't know what the latest is on that specific I guess, where we are in that specific part of the cycle. But I know that this last round was renewed a few years back. There's a better outlook over the horizon for, the cliff is not going to be a cliff to fall off of now. GE is very much investing a lot in the wind still. So I think that could tell you that, hey, as we split off into our own separate entity, GE Vernova, the investment into the renewable side of that is still there. I could think of examples like the money that they're putting into the GE factory in Pensacola right now, gives me some security that, hey, they're not thinking about getting out of the wind business anytime soon. There's a good outlook there. We're in the middle of developing our next generation of our Sierra platform, which we expect to take off in the United States, just like our previous platforms have. Um, I think as far as like the tax credits go, the other thing we're doing is we've been working to get our product more competitive in a post-tax incentive environment. So getting that cost of energy, basically the COE down, to be competitive with other forms of energy such as natural gas, coal, oil, things like that.
Oh, yeah, that's really great to know. How would you say the competition between other wind companies are for you? Because I know in New York State we have many companies competing to be on the offshore coast of New York. So what does that look like for you in Pensacola?
So I don't have a whole lot of background on the offshore part of the business. I'm strictly onshore.
Oh,
So we're pretty well divided with, that fence. I don't really have a whole lot of insight on what happens on the offshore side of the business. We have competitors in the US on the onshore side, though, like Vestas, Siemens, companies like that. From our market share is pretty solid. And I think that, part of our strategy of kind of honing in on certain our workhorse platforms and trying to offer turbines that fit within what needs to happen in a region. So what works over in Europe as far as the type of turbine doesn't always work over in the US because there are differences in the grid. We have more land, so it's easier for us to put a bunch of turbines on the same piece of on a piece of land versus them. They have less land to work with, so they need bigger turbines to work on this smaller footprint. I don't know what our market share numbers are exactly at the moment, but we're usually pretty much at or near the top North America.
okay, that's great to know. Um, are there any misconceptions about the wind industry that you would like to clarify? Because I know you just clarified like there is a difference in onshore and offshore um work environments. Is there any other misconceptions?
Oh yeah, I mean, I mentioned the political environment, right? There's a very wind turbines seem to be a hot button topic, and you talk about national politics and the scenes, and depending on what side of the aisle you're on, and if you're pro green energy versus not, there's that whole debate. But what I notice is seeing a lot of misinformation on there about what it really costs to build a wind turbine and how they'll never pay for themselves, and there's no payoff period for a wind turbine, and all the oil it takes to build it count, all that kind of stuff. So I would just be cautious when you see those sorts of critiques, because you can usually dig into those numbers and see that it's a lot of it's just scare tactics to make a political point or to try to scare people into thinking wind turbines are bad. um can't really, won't really go too much further into that necessarily as far as, well, I think thinking of some of the specific posts I've seen where they way overshoot for instance, an example, the amount of oil in a wind turbine, right? You'll see posts about, oh, these things use 6,000 gallons of oil a year, and it's nowhere near that. So it's an inflated number to scare people. The same thing for how much energy it can takes to build a wind turbine and how it will never actually produce that much energy in its life. Those are demonstratively false as well. So I would say when you see general public critique of wind turbines industry, be very cautious of that, because in most cases those are just scare tactics.
Yeah, that's something I've learned recently too, that working with the community, it's like one of the most difficult parts because a lot of them don't believe in wind energy and wind turbines. Is there something that GE Vernova does with the community to get people more pro wind energy?
So they have, social media campaigns across all the various platforms, different accounts to follow where they put out facts about the wind turbines. I'm trying to think of any specific campaign where I could think of where we've targeted misinformation. I think we try to stay out of those debates because a lot of those are, majorly play out in the public eye or are political based. And I think we have to be careful of trying to get too far into one side or the other, those kind of things. But if you think you have it hard up there where you're at, I mean, I live in the deep South, right? So you can imagine how the political, leanings are down here with those sorts of things. At a local level, we do get involved in the community, but it's more community service based versus trying to educate the public on, green energy and things like that.
Oh wow, that's interesting. Yeah, it must be different in the South. I know New York is very pro environment, even the people. So, um, thank you so much for sharing all of that information. It's nice to see what it looks like in the South. The last question for me before I open it up again to others in the audience is that does G have opportunities for students to engage and explore internships like you went through, or careers at the moment? And is there something that you are looking for or that GE is looking for when they're hiring?
So currently, I don't know. I used to recruit, so I used to go back to the University of Florida every year and recruit. So I was much more tied into the current demand for those programs. Um, we do have internship programs. So we have like the Edison program is our internship slash rotational program for the engineering side of the business. And then the OMLP, the Operational Management Leadership Program, is our internship slash rotational program for like the supply chain side of the business. Normally those opportunities are, if we don't directly recruit to a specific school, normally those opportunities are still posted on the website. So like careers.ge.com. That website is where I would say, without knowing anything on my own, like go look there. But I can speak to your second part of your question about what you're looking for there. When I go back to my time as a recruiter, and I get handed a resume, and then I've got, they've got about 15 to 20 seconds to talk to me and then make a quick judgment call really on if I'm going to put them in a pile to talk to later or not. You're looking for clear communicators, kind of that kind of air of confidence about you that you know what you're talking about. When I think about resumes, like I mentioned, I already touched on experience earlier. So really it comes back to like the communication and kind of that executive presence about yourself.
Okay, yeah, that's great to know. Yeah. Here we're trying to educate as much of our campus as we can about wind energy. So that's great to know that you're looking for confidence about knowing what you're saying. Um, Thank you so much for sharing. Like